Okay, we want to learn how to solve an inequality. The absolute value of 3x plus 2 is greater than 2. First, I want to think about what it means to calculate this absolute value. The absolute value is the distance from 0. So here we have a graph, y equals 3x plus 2. And we're interested when that graph is a given distance away from 0. So here is the y equals 0 line, and we're interested in measuring the distance between the graph and the line. And the distance between the graph and the line needs to be greater than 2, which is why we've drawn two lines that represent our thresholds at y equals plus 2 and y equals minus 2. So as we think about going across the x-axis, anytime the distance from the 0 to our graph is greater than 2, we'll include the point, but anytime the distance from the axis to the curve is less than 2, we don't include the point. So we're interested in all of the points that go up to this point here, and then once we leave, all of these points here. So let's look at the algebra that we would do to find that set. We're interested when 3x plus 2 is greater than 2, which corresponds to understanding these values where I'm greater than 2, which will give me the solution set to the right, or when 3x plus 2 is less than negative 2, which will give me all of the points corresponding to the solution set on the left when the graph is below the y equals negative 2 line. Solving the inequality, subtracting 2 from both sides, we get 3x is greater than 0, or x is greater than 0. For our second inequality, 3x plus subtract 2 is less than negative 4, so x is less than negative 4/3. So I have two sets. And when I get my solution set, I have a number line. I have my 2 points, 0 and negative 4/3. And my solution set will be, not including 0, all points going to the right, and not including negative 4/3, all points going to the left. For a final answer, given by the intervals negative infinity to negative 4/3, not include the endpoint, union for the second set, 0 to infinity. And the reason I have a union is because of the word or. That tells me I'll take a union of my two sets. Now let's consider another example. Solve the inequality. The absolute value of 2x minus 5 is less than or equal to 2. This time I want to do something a little bit different. I want to interpret this in terms of distance, and so we want to know when is the distance from 5 to the formula 2x less than or equal to the value 2. Well, okay, that means I need to graph two things. We're going to graph y equals 2x and y equals 5, and we're interested in the distance between those two parts. We start by looking at the graph y equals 2x, and secondly we have the formula y equals 2. Sorry, y equals 5. Now, I want to know when the distance between y equals 5 and y equals 2x is less than or equal to 2. So I measure the distance from the green curve to the purple curve, and if the distance between those two curves is greater than 2, I do not include it, but when the distance is less than 2, I will. And notice I found two threshold lines. Adding 2, I get y equals 5 plus 2 is 7. And going down 2, I get y equals 5 minus 2, which is 3. I am interested in the points where the graph is between those two curves. So I will create an interval of all of the points where my y equals 2x is between the threshold 3 and 5. What does that mean algebraically? It means 2x needs to be less than 7 and 2x needs to be greater than 3. And the reason I need the word "and" is I need to be both above the lower threshold and I need to be below the upper threshold and below the upper threshold and above the lower threshold. Now, algebraically, I just want to point out that I could have gotten the same thing if I'd started with 2x minus 5 is less than 2 and 2x minus 5 is greater than negative 2. And a lot of students prefer to start from this perspective and then solve the inequality. But as we get to limits, it's important that we can think about the distance between two curves. So when I solve this, I get x is less than 7 halves and x is greater than 3 halves. So what does this mean? X is less than 7 halves corresponds to, let's draw a number line. I have 2 points. I have 3 halves and I have 7 halves. And the first inequality, x is less than 7 halves, says I am less than 7 halves. It's an interval, infinite interval to the left of 7 halves. The inequality x is greater than 3 halves is an infinite interval pointing to the right of 3 halves. And using the word "and" is code for finding the intersection, which means where both of those values are satisfied. And this corresponds to an interval of all the values between 3 halves and 7 halves. And my final solution is the open interval 3 halves to 7 halves. Oops, except, let's go back and double check, less than or equal to. And so everywhere that we had less than, we need to change to less than or equal to, and greater than changes to greater than or equal to. So I fill in the points, and I fill in the points of my final solution so that I get the closed interval from 3 halves to 7 halves. That's how we solve inequalities involving absolute values.